The next is sum of the exterior angle. So again, we can get an expression for that. So let's use what the cheapest polygon we know, which is a triangle. So if you extend each of the exterior of the sides, you notice we'll form an exterior angle. So let's call this theta 1, theta 2, and theta 3. So why the interior angle? Let's call it theta 4, theta 5, and finally theta 6. So you notice we can derive something very, very important here. We notice each of them at every, there is a linear, they always form a linear pair. The interior and the exterior angle forms a linear pair. So I'm saying that theta 1 plus theta 4 is always 180 degree angle on a straight line. So that's equation 1. The same thing, theta 2 plus theta 6 will always give us 180. The same argument. The same thing here, theta 3 plus theta 5 gives us 180. So we are getting a very important formula here. This is equation 2 and equation 3. So adding all the equation, implies that we add theta 1 plus theta 2 plus theta 2 is the sum of interior, while theta 4 plus theta 5 plus theta 6 is sum exterior. It's always equal to this 180 plus 180 plus, which is like 3 times 180. Remember, we are looking for the sum of the exterior angle, so making it the subject of formula. Sum exterior is now 3 times 180 minus sum interior. And remember, this is a triangle. The sum of the interior angle is 180. So we factor 180. We have 3 minus 1. So finally, this 180 times 2. We have 360 degrees. So is a constant. So the sum of the interior angle, the sum of exterior angle is always 360. So for any polygon, so I use triangle to show to prove the theorem. So the next one is a regular polygon. A regular polygon is just a polygon with equal size and angle. That's the size and angle are congruent. So I'm saying that a regular polygon is equiangular and also equilateral. So equilateral, all sides are equal congruent, while equiangular, all angles are congruent. So that's it. So any polygon with this property is called a regular polygon. So the next one is each interior angle of a regular polygon. So with this, since all the angles and sides are congruent, so meaning that each of the interior angle have the same value or the same measure. So each interior angle of a regular polygon, so since they are equal, we need to divide by the number of sides, and the total angle is like giving 20 oranges to be shared equally among 5 people. So each of them will get 4, meaning the total. So our total here is n minus 2 times 1, 8. Why the number of people or number of sides is n. So this is very, very, very important. So the next one, the sum of each exterior angle of a polygon. Each exterior angle of a polygon. So the same way, each exterior angle of a regular, remember it must be a regular polygon. Each exterior angle is also divided by the total. Divided by the total number of sides and the total angle, which is 360. So it's a very, very important formula. The next one is now the relationship between the central angle and exterior angle of a regular polygon. With this, since a regular polygon, all the angles and sides are equal, we can now get the central angle. The central angle is also the total. Okay, let me use a regular hexagon to show you how. This is my regular hexagon. So notice that we form six equilateral triangle. So meaning that the central angle here is the total is like a circle. So which is total measure is 360 over the number of sides, which is n. So for a hexagon is 6, for a pentagon is 5. So that's it. From here we can now say that the central angle of any regular polygon is the same thing as each exterior angle. That's exterior angle. Or each they are the same. So central angle equals exterior angle for a regular. This is only for regular polygon. So the next one is apothem and radius of a polygon. The apothem and the radius, that the two are they differ. They are not the same. The apothem of a polygon is just the perpendicular distance from the center to any side of the polygon. So I'm saying that if you have a polygon, so the apothem is the perpendicular distance. So this distance from the center to any side is called the apothem. While the distance from the center to the vertex, to any vertex, is this distance is now the radius of the polygon. So the radius is just the distance from the center to the vertex, while the apothem is the perpendicular distance. It must be a perpendicular distance. So also we can redefine this. We can redefine the two. If you notice, if I want to inscribe a circle, I'll use this radius. This is a radius. So if I want to inscribe a circle inside this polygon, you notice the radius I will use is the apothem. So apothem is also the radius of apothem is also the in radius of the polygon. In radius of the polygon, or the radius of the inscribed circle. That's the meaning of in radius. Why, if I want to circumscribe, if I want to draw a circle, if I want to circumscribe, that's I want to inscribe the hexagon inside a circle, which is a circumscribed circle. You notice that the radius I use is now the radius of the polygon. So we can now redefine radius of a polygon as the radius of the polygon is the circumradius of the polygon. That's the polygon, the radius of a circle circumscribing the polygon. So that's another definition of the two. So the next one is now the area, which is very, very important. The area of a regular polygon. Area of a regular polygon. So it's why we chose a regular polygon, because it's easier to derive the formula. But for irregular polygon, it's hard. So let's take a hexagon. Let's use a hexagon to derive the formula. So if you have a hexagon, with center O, you notice that by joining from the center, we form 6 congruent equilateral triangles. So assuming the side length, assuming we take the side length as x each. So remember, the distance, perpendicular distance, is the apothem. Let me use A. So here now we form a triangle. Each of these are equilateral triangle. So the area of the polygon is equal to the area of the triangles. The sum of the areas of the triangles. So an area of a triangle is half base. Our base here is x times our height here is A. But we have a total of 6. We have a total of 6 triangles here. So we need to multiply by 6. Each is half x times 8. For the 6 is now times 6. And we can still write this as half times 6x times A. You know, multiplication is commutative. And looking at this, 6x is like the perimeter. So this is perimeter. And our A, I told you, is our apothem. So that's the formula for area of a regular polygon. So that's it, half times the perimeter times the apothem. So with this formula, with these definitions and formula, we can solve any question involving polygon. So let's now enter the first part of the equation, which is the easiest one.